students, I welcome you all for this video session on subject microprocessor and microcontroller lab. Myself, Uday Shankar, Assistant Professor, Department of ISE, SJPI. In this session, we will discuss program number 8, which deals with binary counter, BCD up-down counter, and as well as multiplication of two numbers. So in this, the aim of your experiment is for an 8A experiment, BCD up-down counter. In your previous semester, you have studied this BCD up-down counter using synchronous and asynchronous, so where you will be counting from 0 to 7. So similarly, in this microprocessor, we are implementing using a assembly level language program. So what is this BCD up-down counter? So the counting starts from 0 to 9 and it has to decrement from 9 to 0. So for your syllabus, it's from 0 to 99. We need to count. That is the up counter, and the down counter is from 99 to 0. So we'll see the coding part. Coming to the coding part, you have first we need to initialize the with the dot model small, which allocates your data segment and the code segment. The data segment deals with the different ports. So before seeing that, we see what are the apparatus we need to connect for this. This is your CPU and this is the hardware called as logic controller interface. Okay, it has connected your CPU through this bus. Okay, this bus consists of port A, port B, and port C and control word register. So that you can have take the control of your logic controller. So this is your port A address, port B and port C address to take the control of your hardware, and so that we have initialized first, and then coming to your port segment, you have the data whatever we have, so that will be moved to your data segment. Okay, and then we are initializing your counter register with the value 10 for the execution purpose. For your experiment, you need to initialize this with your 99. So first, we need to count from 0 to 99. For this execution purpose, we will for the video session purpose, we are initializing only for 10. Okay, so 10 times we will count. That is from 0 to 9. So that will be moved to from port A will be moved to AL register. So from the AL register, the out instruction will take the contents of AL register to a hardware device. Okay, and then we have an increment instruction. We have a delay. We need to call the delay to see the number, which number it is displaying. Okay, and then we'll go to instruction AL. So increment instruction, that is AL. So we increment AL instruction will increment the value, one value, whatever is there. So initially it is 0, and then if it is increment AL, then we will increment add 1 to that, so that it will become 1. And then we will go for 2, 3, 4, 5, 6, 7, 8, 9. Okay, till 9 it will go and it will exit. So that is your loop back instruction. Loop back will keep on incrementing the value of AL. So after that, again we are loading your CX register with the count value as 10. So after that, again the movements with the port A address, we are moving the contents of AL, and the out instruction will display the contents of your AL register. Okay, again the call delay is there to see which number it is displaying. So and then we have the instruction called as DEC, called as decrement the value of AL. So actually we are initializing it to 0 for the first increment for the up counter. Now it is down counter. So now the value of AL is 9. We are initializing it with 9. So that when you decrement, it starts from 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, till that loop will be executed. The loop will be happening. So once it is reached 0, it will exit from this loop. Okay, and then move AH4 instruction and in 21H is your terminate the program. Okay, so this is your programming part. Okay, so we'll see the execution now. So coming to the execution, so you have the different commands. So you have the MASM command first, you need to execute. So to check the warnings and errors. If there is no errors, the object file will be created. So next, link that particular object file which is created. So once your object file has been run, then you can go for IOPF, input output permission for the hardware. Now you see the output. It started counting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again start from 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. Okay, so this is your complete execution of your program 8A-BCD up down counter. This is your execution of BCD up down counter. So coming to the Viva questions, they're going to ask what is dot model small. So what type of memory will be allocated to? What is dot data? What is dot code segment? Which are the different segments you have it with this? And then you have different instructions and notice the delay procedure. These are all the different Viva questions you can expect in this particular experiment. We'll see the next program multiplying 2 digits and displaying the result in the logic control. So in this, the aim of this experiment is to take the input from the hardware itself and we are displaying the result in the hardware. Okay. So again here we need logic controller to be connected to the CPU to take the input as well as the output. So while coming to the coding part of this experiment, so dot model small, dot data, it initializes dot data and dot code segments. So code dot data. So for this, again as I said, the logic controller is connected to the CPU. Okay, where again the bus is connected to the hardware and the CPU. Okay, so you can take the control of this complete hardware device using this bus. So to initialize this, so we have the port A, port B, port C control registers. Okay, to take the control of your hardware device, and then we need 2 variables where we need to store the values of x and y. Okay, and we need 2 messages. Okay, so when we need to enter the value of x and when we need to enter the value of y. Okay, so get to know that we have 2 messages will be displayed for. Okay, and then coming to the code segment, we have a macro for this display macro message with effective and load effective. Any instruction stands for load effective address. Okay, so it loads the effective address of the value x. Okay, that is the memory, the starting address of the value x, where you can store the input received from your hardware. And then coming to the next instructions, you have the initialization of your data segment with the required data, and then you have move AL, 82H. So this particular line will help you to take the control of your hardware. Okay, so and then you have the display message 1. So in this display message 1 will display enter the value of x as you see in as you have done in your data segment. Once you get that message, you will enter the value of x through the logic controller. So once that is done, then you can go for the enter key, so that the value whatever is there will be fetched and stored in the value AH. From port B, you have the in instruction. So in instruction will help you to fetch the information from the hardware and stores it in AN. Okay, so whatever the value will be stored in AN register. Okay, and move that particular AN to X, and then display the information message, second message, that is enter the value of Y. Again repeat the same procedure, that is to move the port B address, whereas in instruction fetch the information from your hardware, whatever the information you are getting it, and store that information in AN. Before it was storing the value of X, now it stores the value of Y, and move that particular AN value into Y. And next instruction is MUL. MUL instruction will perform multiplication, okay, with the X. X is the previous number and currently you have the Y. Okay, both the information will be multiplied, okay, and then the final result will be sent through the DX. Okay, you have the simply stored in AL register again, okay, and then out DX comma AX. Okay, whatever the AL value is there, that will be sent out through DX. Okay, that's the meaning of out instruction. Out the value of AX, that's the result, will be sent to DX. Through DX, it will be sent out, that is to a hardware device. Okay, then you have a called delay is there. So delay will helps you to display to see the final result. So that is the delay. And the next instructions will be used to terminate the program. Okay, you have the delay procedure. So as usual, regular procedure. You all know this. Okay, so this is your programming part for your multiplication. Okay, we'll see the execution. So execution. Again, the first instruction will is your Amazon space a file name dot ASM. Okay, to check for the warnings and errors. If there is any error, then it will show the error. If there is no error, you will get 0 warnings and 0 errors. So that object file will be created. The next step will be link that particular object file to run the program. So then you have IOPM, that is your input-output permissions. So when you see the enter x value, then here we are not supposed to enter the value of it. So what we need to do is, we need to minimize this, close it, and then go for the command prompt once again. Then CD overview, CD stands for overview. You need to run this one. Now you press G. Now we need to enter the value of x. We need to take the value of x from the logic controller. So this is a logic controller. So you have the values here. Okay. So from this we need to take the input. So I will take the input as 2. So this stands for. Okay. So this is 1, 2, 4, 8, 16. Right. So I will take the 2 as the input for value x and I will press the key enter. Okay, now the next value has to be taken as y. Okay, y is, I will take it as 4. Okay, so this is your 4. Now I will press the enter key button so that I can see the output in the program. See the control logic. So 2, I have taken the value of x is 2 and y is 4. 2 4 is 8. Okay, so this is your 8. 0, 2, 4, 8. Okay, so 8 is the output. Okay. So this is how your multiplication of two variables in your assembly language program. Coming to your Viva questions, they'll ask different instructions like that. What the in instruction will do, and what are the different port addresses, and then you have different segment addresses and delay procedures. You can see the interrupts, different interrupts you have. Thank you.